I'm going to get started. Thank you for coming. I'm Joy, and we have several volunteers here. Can everybody hear me?
Yeah, we hear you really well.
Okay, usually you have to put it really close. So I'd like all the volunteers to raise their hands so that we've got Dorothy and Pam in the back, and Tom is in front, who doesn't want to raise his hand, and Bill.
I'm not a volunteer, I'm a drafter.
Yeah.
So if you have any questions about our group, then you can talk to any of us. We're the Fallbrook Climate Action Team. We're an issues chapter of Organizing for Action. We're an all-volunteer group, and we will be having our planning meeting, our monthly planning meeting, on Thursday at the Bean and Bug in the meeting room. So if you're interested in working with us, you're welcome to come and join us at 1 o'clock. And Pam has survey forms, so if you haven't been here before, or even if you have, what we would like you to do is after the program, fill out the feedback form so you can tell us how we did or how we could improve. And I'd like to introduce a man from Fallbrook named of Jim Jones, who's here, who would like to give us a update on the San Onofre nuclear waste disposal. And he's just going to give us a short update before we introduce our main speaker.
Thank you, Troy.
Sure.
Thank you guys for coming out tonight. It's great to see that there's people who are actually concerned about the issues that are going on. I know from doing a lot of effort in this area that it's hard to get people to actually pay attention, so thank you very much for being here. I put on an event called Music for the Revolution, or it's a nonprofit that's called Music for the Revolution. We have a festival that happens on October 8th, and our focus this year is on the nuclear waste issue at San Onofre. And a lot of us have heard some of the news reports that they reached some kind of settlement with the lawsuit that was pending, and thought that everything was settled and they're moving the waste off of the beach, and I just want to report back that that's absolutely not the case. What happened with that is that Southern California Edison agreed to pay $4 million to hire consultants of their choosing to see if they can find a financially feasible option to move it off the beach. So there's absolutely no plan of any substance in place to do that, other than they're saying that they want to look into seeing if it's possible. On top of that, the normally scheduled date of January for putting the nuclear waste into the beach has now been pushed up. According to the last community engagement panel that they had, they're saying that they might now be trying to put it in starting in November. So once they get this in the ground, it's going to be a whole different game. It's going to be a lot more difficult to get that out. If you're not familiar with what I'm talking about, it's basically 3.5 million pounds of nuclear waste that went in a tour on the beach at San Onofre, basically 108 feet from the water, and in canisters that are only guaranteed to last for 25 years. So it's not a very good situation, and we're working hard to try and get that reversed. One of the things that's happening at our festival is we've got an organization out there called Public Watchdogs who's been doing a great job at trying to educate the community about what's going on, which is really our only tool right now, is getting enough people to know what's happening, to be upset about it, that they can cause some kind of social pressure on the powers that be to think about doing this differently. So they'll be there with a petition that's going to be hand-delivered to the Coastal Commission. The Coastal Commission is the one that granted the permit for the nuclear waste to be buried there, and they're having their public meeting the week after our festival. I think it's going to be on October 11th is the particular date in San Diego. As well, we've got a group, San Diego Water Protectors, who's going under a new organization called Immersis, that'll be working with the kids at the festival to actually have them create cards that they're going to hand deliver to the commissioners at the public meeting. So if you would like to be a part of or be involved with the festival, let me know. We do have specials on tickets, and there are volunteer positions available, so if you'd like to help out with that, we'd love to have you help us. And Joy, thank you very much for letting me have a moment to update everybody.
Thank you. Great to see there's so much activity in Fallbrook now. When we first came here, people said there was absolutely nothing going on, but now there's stuff going on. Now I'd like to introduce Dr. Richard Minnich, our featured speaker tonight. He's from the University of Riverside. He's a fire ecologist, and he's an earth sciences professor there. So, with no further ado, thank you very much for coming.
Thank you very much, Joy. And it's a pleasure to be here in Fallbrook. We are going to go through some historical exploration of what has happened with burning in Southern California to address this very important question, and that's the role of global warming on the patterns of fire. But we also have to take account for the effects of fire management also over the past 100 years that make it more difficult to address this issue. That's the beauty of it. We have, and we're going to look at this area in brown, which is the chaparral, and it happens to transcend 2 countries. The United States, where there's been suppression for 100 years, since 1900, and in Baja California, where there was free burning until very recently. Free burning is a word that means that there's no suppression interference. And so we now have a little a natural experiment for which we can test whether we got global warming effects. So let's look at and I'm going to call the region the California borderland, which includes the 2 countries. So we got suppression and free burning, and because we have 2 different management systems, one with a lot of management, one without, we can test for these questions. If global warming, if fire management, what are the effects of fire management? If there is none, then there would be no difference in the fire patterns across the border. That's one way to look at it. Another way to look at it is if there's free burning in the 19th century in Southern California, it should be similar to modern-day Mexico. Is that true? Well, we'll test for that. And finally, global warming should affect both countries simultaneously. After all, it is global. So, first of all, we've got to look at suppression and what it means. The comments on the bobblehead thing are my daughter's when she was only 10 years old, so ignore that. But this is what happens in suppression, and it comes in 3 steps. And I might add, there's a major burn taking off right now along Interstate 91 in the Santa Ana Mountains. It's just exploded, and it's in the news. I don't know if you've heard about that. And boy, you don't know how to pick them. You got a major fire taking place in the Santa Ana wind. This is one of the problems that we're going to be addressing. Suppression comes in 3 steps. Initial attack, meaning putting the fire out as soon as you can. Nip it in the bud. Get it as an ignition. Very effective. 99% of the fire starts are put out at an acre or less. Secondly, if a fire does get large, then you surround it and control the perimeter to keep it from spreading any farther. And the third is, once it's no longer spreading, and that's what they're calling containment in the news, then you mop up to make sure there's no fire recurrences. The fire could just take off again willy-nilly. So that is what we see, and this is what's in the newspapers. There's always coverage saying, well, fire take off. There's all these forces there. We got helicopters and now jets and bulldozers and all the rest trying to put the fire out, plus tremendous manpower that's moved around from various parts of the West United States. Now, I'm going to point out that this is really not fire suppression, it's fire selection. Because of all those processes that we do to try to put fires out, the only one that's effective is nipping it at the bud at the initial attack. After all, at this point, the fire is tiny. You can get a one-hand crew in a truck and surround it and knock it down right away. Now, you can say this is success, but all it does is buy time. It does not manage the vegetation. You can put it this way, if you save an acre of chaparral, that same acre will eat you later. You got to look at this in long time scales, not the immediate. So fire selection, if you're really good at putting out every little ignition, you're going to select for ignitions to take off in more extreme conditions than by chance. Fires could burn in a huge range of environmental conditions, like an ordinary day in summer. Not Santa Ana winds, but that's what's happening, just Santa Ana winds lately. And it's happening today. It's a classic case. If the weather today were like 3 days ago, that fire in Santa Ana Canyon would not have taken off. They would have nipped it in the bud. Think about that. It's a Darwinian thing. We are selecting for the most fit fires. Okay. So now, there's societal education in the media, and I'm sorry, the print's small. One is, that you see this in all in major fire reporting events as we're having now, is that ignitions cause fire. You hear this over and over and over again. We'll bring up that. Fires correlate with drought. We're going to answer these questions one by one as we go along. Fires were always large, in the scale of tens of thousands of acres, and lately 100,000 acres or more. Fires occur in Santa Ana winds. It's happening today. And there's been increasing fire size with global warming. I will make a case that we are making, this is a classic historical example of Orwellian science and Orwellian propaganda, and we will go forward through this. We need to look at this problem over long time scales and test for it. So, ignitions cause fire, okay? And the reason there's a demand, and fire therefore is unnatural because it was set by man. Now, is that really a valid statement? And I'm going to just go right past this slide and go to the next one. It's an error in first cause logic. A causes B. Because we're looking at two different time scales. An ignition is instantaneous, a split second. The vegetation which carries the fire develops enough mass and energy to carry a fire not in a split second, but over decades. And the combination of an ignition striking vegetation is capable of propagating the fire reaction. It's not the ignition that's doing it, it's the vegetation that's carrying the fire. Or, if I can perhaps be sarcastic here, but you can send an arsonist to Death Valley and he'll never get arrested. Okay? So, consider the reverse. If you have a fire that burns a huge watershed, that affects future ignitions on that watershed, regardless of the source. So you've got to get away from this first cause logic, ignition cause fire. It doesn't teach us anything. So it's also like saying, and you would never agree to this, right? Snowflakes cause avalanches. And then you ask, well, which snowflake? Which is the one that's falling in that snowstorm that puts enough weight that it triggers that avalanche to slide down the slope? Or raindrops cause floods? Or epicenters cause earthquakes? Well, it's not that. In the case of earthquakes, it's crustal motions that produce the earthquakes ultimately. And floods are a result of cyclones and tremendous rainfall, like we had in Texas recently. And here we are, snowflakes causing avalanches. That one snowflake that was the tipping point of biomass where you could finally get that snow to slide because of its weight, is one of many snowflakes that was falling at the time. And we're worried in fire ecology, ignition causes fire. It's analogous to saying we're worried about which snowflake started the avalanche. And it's meaningless. So, you've got a scale problem when you take that position that ignition causes fire. Or, I like to do this. I do this in my class. Smokey the Bear says, you know what we say, help prevent, right? Okay, can we do that? Can we stop cyclones? Can we stop, hurricanes? Of course not. We wouldn't even consider it. We have a man versus nature power relationship where we understand that one is bigger than the other. When it comes to natural hazards and disasters, what we are do best is to get people out of the way of major powerful situations. For example, the hurricanes recently, in the eastern United States, in Texas. So, let's get to science in a rational frame of reference. And first of all, since I'm from the Department of Geology or Earth Sciences, I want to deal with how long we've had fire on this planet. First of all, there are 3 ingredients necessary for wildfire. One are the ignitions. But there's been lightning ever since the atmosphere first formed. And lightning not only occurs on Earth at rates of millions of strikes per day and billions of strikes per year, massive amounts. If you accelerate time in a time-lapse movie, every landscape, including Fallbrook, has lots of lightning. It's a ubiquitous resource. It's always been there. Just because we can't remember the last lightning strike does not allow us to make that assumption that lightning is rare. It's actually abundant in ecological timescales. Oxygen. Well, there's free oxygen buildup to modern levels roughly 600 million years ago. And it's at that time that we finally got into metazoan life, that is, plants and animals showing up in a fossil record. And then the third thing you need for fire is to have land plants. Seaweeds will never catch on fire. They're a plant, but they're sitting in the water. But land plants did not evolve to a point where they were growing on continents until 400 million years ago. So all 3 ingredients, oxygen, remember, 21% of our atmosphere consists of an explosive gas. It's called oxygen. And ignitions have been ever since the day one on this planet when the atmosphere first formed. And all 3 ingredients have been here for 400 million years, and that's a long time for plants to adapt to fire. So lightning in the primordial earth, the first land plants, 400 million years. And then I want to emphasize, as a geologist, that fire, just like floods and erosion, is an Earth's surface process. It's been around over geologic timescales. Now, I thought, I'm writing a book on this thing, but I had to figure out how do I, one word it gave me to allow me to describe what I just told you. And the best is interplay. There is an interplay between fire and vegetation. If you think about it, then the plants are both the source of the fire, they're the energy, and they're also the recipient of fire. Both simultaneously. So when one way, and it's a philosophical perspective, one way to look at the fire process is when flames move through the vegetation is not being burned by fire. The plants are burning themselves. They're the ones, through photosynthesis, have been accumulating carbon dioxide out of the atmosphere through photosynthesis and making organic matter, which is energy. That's the source of burning. And so here we are, the photosynthesis equation. And not only the plants are burning themselves, but they're also producing and have always produced the oxygen that filled the atmosphere that allowed this process to occur. It originally was plankton in the oceans 500 million years ago or before. So fire is both rapid oxidation and, I might add, is one other thing. It's inorganic decomposition. All organic matter ultimately, in long time scales, breaks down. So fire is what? It's a metastable process. Good word to know, okay? There's a stable growth phase. There's a long period of time where the plants grow. And then there's a follow, in this climate, with instantaneous breakdown of the organic matter. That is, the vegetation is burned. And then it starts building up growth again in the next stable phase. Most of the parameters that affect the course of a fire are actually fixed or ubiquitous. Lightning is ubiquitous. We've always had a lot of it. The terrain is fixed. These hills are not going to change right away. And there's free oxygen, but it's at 21% everywhere through the planet. So they're important to the process, but they're not really variables. Okay. So what is the variable? And it's the vegetation, growth, and fuel production. And that varies around the planet. Some places grow lots of stuff. Other areas like the deserts don't grow much at all. And that affects how much burning that takes place in the vegetation. So my view is that the source, or quote, the cause of fire, big quotes on it, is the vegetation. If you want to understand how the fire process works, examine it from the standpoint of the vegetation. And in the global warming scenario, the same. So, and also in the long run, ecological timescales of decades or centuries, there has to be another conservation of biological mass. What grows, and that's what I'm calling plant production, we call productivity, also has to break down. And it can be done through microbial action, small organisms, microbes, molds, they're breaking down organic matter all the time. But what is not broken down biologically is also broken down through combustion. So what about the distribution of global fires? It's in red here. The whole planet is susceptible to burning in varying degrees. The only places that don't burn are ice sheets, the ocean, and deserts, pretty much. And there are some areas where fires are frequent and abundant and widespread, and other areas which are not. And California has this incredible situation of Mediterranean climate, which is unusual for the world. Most of the world gets most of its rainfall in this summer growing season. We get it in winter, and then we have this long drought combined with heat. So I'm going to give you 3 examples. If you're in the rainforest in the Amazon, extremely productive. Oh, fuel, but also very rapid decomposition. There's hardly any available fuel to burn in the tropical rainforest. In the deserts, wow, low decomposition, but it's combined with little growth because there's so little rainfall. Deserts don't burn much at all. And in California, we have, especially in the chaparral, but most of the vegetation, high growth rates combined with little organic decomposition. And so as a result, most of the energy is cycled inorganically through combustion. So, here's a picture of chaparral. And I'm not being sarcastic. I really want you to think about that question. Which side at this split-second photograph is most flammable?
I mean, right now or before the fire that just occurred?
Right now. Right there. Which
The one on
side?
the right.
Right, of course. And that's what makes fire metastable. The left was the right, and now it's denuded, and it's not a fire hazard. Every time you have a burn in the landscape, you've got a grace period to follow where you really don't have a fire threat for a while. And on the right, it's next in line, so to speak, to the next burn. Now, this is a very important concept because on the landscape, you've got a patch mosaic of different stands dating to different fires at different age. And there's preferential burning in chaparral in the oldest stands, such as the one in the Santa Ana Mountains right now. Okay, so now the shifting baseline syndrome, really important idea. came out of UC Scripps actually about, 10, 15 years ago. What it says is that the story you tell depends on when you start the story. If you start the story in 1911, and that's Forest Service records, it's already too late to understand what the free burning baseline was in California. But if you can go back like a half a century, and I've done this through years of research, we can actually address the era of free burning in California to find out really how the fire process operated without human interference with it. Now I'm going to go to only one proxy record before I move on, and that is fire scar dendrochronology. But trees get burned and scarred and then constantly heal themselves through cambial growth in the bark, and then the fire scars can be counted in between the rings, and they can suggest how many fires occurred, at least at that tree. But in a study that looked at many, many sites all over the southwestern United States, we can see there's a steady state from 1700 to about 1900, and then the fires suddenly tail off. I don't care about fire scar dendrochronology, but that is one very good result that came out of it. It shows that in the last 100 years, we suddenly went into an anomalously low rate of burning compared to probably not only what happened in the previous 2 centuries, but probably all of the Holocene over the last 10,000 years under the modern vegetation. Historical records of fire in Southern California. I've always been amused by what this, but people had not only reported different properties of fire that we had in Southern California, but they also, it's humorous and it's a different perspective than we have now. So as early as 1869, for example, there's a comment that says lightning fires on the north slope of San Bernardino Peak, San Bernardino Mountains, and Cucamonga Mountain, which nobody did anything about. Now this isn't a newspaper, all these are newspaper quotes. That's one thing. And quite often you see the remarks saying, well, the fires would probably burn themselves out. You know, they didn't really. They were just observations. Then another observation, and this was also in 1869, but it's like many other times. For 4 or 5 weeks past, the fires continued to rage in the mountainsides. 4 or 5 weeks, okay? Not 5 days, not 1 week, not 3 days, not 1 day, but weeks. Remember, summer drought. There's nothing to rain these things out. Once the fires get going, they're going to keep on going for a while. And then the attitude people had. One of the prettiest sights I've ever seen was a fire on the top of the mountain. This was very common in the 19th century. When people are growing citrus trees and growing crops, and especially you've got people gradually moving in the Southern California region and observing land that is quite removed from the eastern United States from where they came from. In terms of theory that came out of the 19th century, there are 2 that came out that got us into suppression. One is the sponge hypothesis, and the other is ignition caused fire. We've already talked about that. I'm not going to belabor it. The sponge hypothesis was the key, and that is, the watershed was, if you have a lot of vegetation on it, it behaves like a sponge and holds the water there. And that means there's going to be more water that's going to, for the people who are irrigating their crops down below, or for domestic use in urban areas. The problem with that hypothesis is it completely doesn't understand transpiration, which is something was actually already known to science. But plants are water pumps and nothing less. So when you got a big sponge out there, you're actually using the water and spending it. There's less water available in the creek beds, not more. But the 19th century folk bought into it. And when fire suppression was first proposed, and this was done in the 1890s, the people, and this is after a couple of major fires around Mount Wilson, in Pasadena, the people in Pasadena and the LA Times were all upset, and they said, we got to do something about it. And the rest of Southern California, far removed from the mountain, said, we don't give a damn. How do they get into making didn't worry about it was this one, saying, well, you're going to have less water to drink in Long Beach because we're ruining the sponge with these major fires. And so it finally got them to buy in, and so we got into suppression. There was some really interesting theories that came out during the 19th century. Fires cause heat waves, not the other way around. They said, after all, when there's more smoke in the mountains, it seems like it gets hotter all the time. The only thing they're really confirming is that the fires actually get more active when it's hot. But they did not understand the scale of what they're talking about. Some fires were blamed to be volcanic eruptions. One of them was in Mount Baldy, and another one in Tockless Peak in 1896. Very good. Another one is fires destroys watershed. That's the sponge hypothesis. Fire destroys forest. They always said the forest was always destroyed. But in fact, when they go in there a month later and they said, oh, well, the forest is just fine. But it was always reported as a calamity. And sometimes people weren't critical about it. Now, what was the chaparral like before suppression? We have wonderful quotes. I'm only going to give you one of dozens. And it's quite impressive, but in the 1897 through 1898, John Lyberg, who did the forest reserve reports of the U.S. Geological Survey throughout the western United States, but including the 3 national forests nearby in Southern California. He described in the San Jacinto Mountains, the chaparral varies from extremely dense to thin or open, but rarely forms large, uninterrupted patches. He described a patchy landscape. And in the same document, he says, for the past 8 years, fires covered 15,000 acres, scattered throughout the reserve in small tracts. He was describing a fine-grained patch mosaic. Similar descriptions came out of the San Gabriel Mountain Reserve reports, the San Bernardino Mountain reports, and also here in the border, the 1894 U.S. Boundary Survey in San Diego County. They said the same thing. And that was everywhere in the free burning period before suppression had effect. Long duration fires. This is a list of long duration fires. There's one virtually every year somewhere in Southern California. How long? Well, here's one that goes from August to September, July to October, okay? Months. And I have 2 that actually went more than a year in the drought of the late 1890s. These fires weren't burning all the time. It was just on and off, on and off. They could always store in a log or a snag and then take off later in dry days. Recognize this can happen. And remember what happened in Monterey last summer. That fire went 3 months in the northern San Lucia Mountains. And I documented 3 fires in Mount Wilson in the 1890s. And all 3 of them went at least 2 months. My favorite one is one in 1898. This is a picture of it. And it's usually what happens in an everyday. There'll be a small little run and a plume of smoke, and then a cloud on top of it in that case. And it started on July 25th, July 28th, and ended in October the 29th. And there was only 3 runs. So out of those 90-odd days, there was only maybe 10 or 15 days where there was active fire spread. That's typical. So it's not an ongoing process, it's just intermittent. Now, that's one thing. I can just say this is what people said. Another thing is you can use those same quotes and then use 2 other sources to make a spatially explicit reconstruction of the fire patterns. They, quotes of the LA Times and others, use modern place names. You can locate where these fires were. And then you go to 2 sources. One are these first aerial photographs of the region in 1938. And believe me, fires in the 19th century were well recorded on these photographs. And you could still see immature areas of trees, areas that had been burned like 30 or 40, 50 years before. And secondly, if you don't care for that, there are ground photographs of rich orange growers who had cameras between 1880 and 1900. And they can also verify these same fires, and at the same time, they show chaparral fires which fade faster because it's low shrub cover. It's easier for it to fade through time, just by the nature of the structure. So, given these sources, and this is one fire, by the way, it's inside that perimeter. It's also shown here on this picture. It doesn't look too good on it from my perspective. And there's a photograph, and this is an error. On July 28, 1899, fires above Skinner in Mountain Home Canyon, and that's actually in this area in the eastern San Bernardino Mountains above Redlands, and on the north side of San Bernardino Peak. And then a full year later, there was several fires above Skinner's. It was still burning in a long 5-year drought, just like we went through, and it just kept going. But not constantly, just storing and moving on. That's kind of rare. Usually the fires are lucky to get to 3 months. This is the fires on Mount Baldy area. It doesn't show very well at all. It's almost too bright, sad to say. These are great photographs, just north of Ontario and Claremont. So what kind of pattern did they show? And this is the reconstruction based on photographs, newspaper reports, photographs on the ground back to the 1880s, and then the 38 photos. And this is the pattern of fire that shows up for the 50-year period from 1863 to 1919. And you'll see that the fires are small to modest. They're mostly moving west to east or south to north. They are elongate. Fires tend to go in the direction of the winds. And it's mostly onshore. Rarely was a fire reported in the Santa Ana Wind. Rarely. Occasionally, there are few reports. And fire size, well, the one in the far left's the biggest one, but that's well into suppression. It's 1919. That's why I made the cutoff. So let's go forward with time. And if you're worried about global warming, the first thing you think, well, if there's global warming, we're going to have longer fires. Well, fires have become shorter in duration through time. Whether you look at the number of flaming days where they're saying fires are actually spreading, or the actual duration of fires through time in 1880 to 2000. They're getting shorter, but that's due to mopping up effects of suppression. That is an artifact of management. Fires are becoming larger. Burn area is increasing. That's one thing you would expect with global warming. So, global warming predicts this because there's greater warmth, it dries the vegetation faster and gets it into a flammable state faster. Let's go through a time series quickly now, so you got to be careful. Note that there's dates at the bottom you can follow, and you're going to see the same polygons through time. Riverside's had star in the middle, and we're going to move forward in time. So the next 10 years, there's a new set of burns, right? Here's 1930s, 40s, 50s, 60s, 70s, 80s, 90s, and the aughts, 2000 aughts. What's your opinion? Are they getting larger? It's a no-brainer. Okay. Anybody want to see that sequence again? Okay. And one in the upper that's purple is the old Grand Prix complex for 2003. And yes, they're bigger. Look at the difference. But is that global warming or is it fire management? So, annual total of burn area. And this is going from 0 to 60,000 hectares, which is 150,000 acres. And we're getting more and more huge fires as you go forward in time. And this is also a 10-year moving average that shows that the rates of burning have been going up, but spectacularly so in the 2000 months. Okay, let's test for this. What's happening at the international boundary? You've got San Diego County. You're in the upper part of this diagram at this location. And the fire pattern in Baja California, reconstructed from aerial photographs that go back to 1938. And we're going to go forward by decade again. And we'll just, and notice, by the way, here we are already in 1920s. And the fires in San Diego County are much larger. The effects of suppression were immediate. They started in 1900, and by 1920s, you were already getting coursing and patch mosaics and much larger fires. It was immediate. And it continues through time. So 30s, 40s, 50s, 60s. The famous Laguna fire, right here, 200,000 acres. 80s, something's happening here. 90s, and the aughts. And as you know, San Diego County pretty much burned up from one end to the other in that decade. But so is Baja. What's going on here? Baja, the fires were small. Still, the mosaic patch structure was dominant, just as Liebert described it in the 70s. Is that global warming? Suppression started in 1970 in Baja California and in this country of Mexico. They bought into it thanks to the United States. Of course it is. And they lost their fine-grained mosaic immediately, like 20 years. So we've had that question. So how does this can help explain how you can get no suppression in smaller burns. What a paradox. Let's look at that. As you go through a fire cycle through time, going to the right, and also visually here from a young chaparral stand that's just gotten starting to sprout and seedlings getting established after a burn, to an old growth stand, two things are going on. Two things are going on to make that stand more flammable. It's not just increasing biomass and fuel. That's this line here. But as the plants get bigger and the canopy gets larger and the leaf area gets greater, it also sucks the water out of the ground faster. So you get plant water, you've got energy as a source, carbohydrate energy, and water is a heat sink, because water can't burn. And eventually you get to a point where the carbohydrate exceeds the water in the plant. And then you get a fire. It's time dependent on long-term processes, 30, 40, 50 years. It's both. Water and increasing fuel. And then patch mosaic is very different. This is the Jacinto Mountains. This is the old Grand Prix fire. It goes 43 miles from Redlands to Glendora, one burn, 150,000 acres. And if you go to Mexico, anywhere, you get a landscape like that, patchiness everywhere, just as Liebert described it. So one issue when you're trying to resolve global warming is what is the effect of suppression? Because there is a huge effect, and it goes right along the international boundary. There's a shift. It's clearly a management impact. It's not climate gradients. So here's an example. Which side is more flammable, the burn side? So these are two photographs 20 years apart showing the mosaic, the patch mosaic. Mature is dark, burn land is light. And in 1938, 1956, the same meadow is shown in both. But you can see how the new fires in the next 20 years are dovetailing into the older stands. Patches affect fires affect future fires. There's memory in the system. What really happens is if the patch age is 0 to 20 years, the fires literally block the progress of the subsequent fires. And as the patch age gets older, then it only constrains. Fires, especially in worse weather, can still penetrate, but they're still going to be slowed down or stopped by subsequent fires. And by the patch age, when it reaches 40 years, then you get free overlap. The maturity of the stand is such you can carry a fire regardless through the patch mosaic. The key is what makes the fine-grained mosaic are these stands that are only 20 years and less. And when you have a successful era of suppression where you knock out all the fires for 20, 30 years, you lose the whole mosaic. And it only takes 20 years to go from a fine-grained patch structure to giant fires. Now that's one side of the coin. It's the patch mosaic and the fuels. So the next question, fires occur in Santa Ana winds in the fall. That's what we're told, and it's happening today. But is that really normal, or is it an artifact of management? So we're going to look at that. Really, if you could generalize all you can about the weather of fires, they're really just summer and fall. In the summer, the jet stream is far to the north into the Canadian border. We really have no winds aloft of any velocity. And the winds are largely dominated by onshore flow, which you see all the time here. You get fogs, low clouds, and westerly winds in the afternoon with the burn off of the clouds. And the winds are moving from the ocean and up into the mountains. This is virtually every day. And if you look at the Mexican fire mosaic over there in the upper right, many of the fires are stripping in the same direction as the prevailing winds. They're onshore and going uphill. That's the one kind. The other, of course, is Santa Ana's. And so here is going to fall. The jet stream strengthens. It comes down to our latitude, and occasionally we get a situation with strong northerly winds in the upper atmosphere and very high pressure in the Great Basin and offshore winds instead of onshore. It's happening today. And these occur really only in the fall, from about now until through the winter months. But the burning is associated with fall. Once you have a rainy season kick in, then the Santa Ana winds don't carry fires. But the Santa Ana wind is by far the worst possible kind of scenario for a fire to spread, because of extremely low winds, low humidities, and high wind speeds. But it's usually only 5 to 10 days per year, roughly. Whereas the summer scenario, we're talking about 100+ days per year. So I checked out the weather data, and actually you can reconstruct the weather of every fire back to 1878. Using the daily weather map, it's an online resource, climatological data, National Archives. The chief signal officer, I really had to go to that stuff from the 1870s and 80s, and old newspapers to find out two things. What are the high temperatures? The high temperatures, that's the time when you have most of the burning in the middle of the afternoon. It's San Diego, LA, Riverside, and Needles, and all 4 stations have a continuous record to the present. And look at the sea level pressure gradient. You want to know whether it's onshore or offshore. And there are a couple other parameters that I'm not going to worry about. We can also get the same data for Baja California using MODIS, because the MODIS imagery is daily. There's a satellite seen every day from that satellite platform. And we can determine the fire status in Baja and put a calendar date on it and then tie in the weather. Just as we already have the same dates for the fires in the north of the border through our record system. And the fires are classified into 3 for simplicity. Santa Ana winds, in red, and heat waves, meaning it's hotter than 100 in the inland valleys, yellow, and ordinary marine air, okay, green. And look at the pattern. In California side, it's mostly Santa Ana winds, area weighted, but it's all red up there. We have a couple of Santa Ana events in Baja, a couple of heat waves, and a lot of the fires occurring in ordinary weather. And there's very different fire behavior in both. First of all, in Southern California, when is the burning? It's in blue. Mostly in that decade of the MODIS satellite platform, 2002 to 2009, it spiked in October in fall Santa Ana winds. In Baja California and magenta, most of the burning is in summer, not in fall. My antagonists say there are no Santa Ana winds in Baja California. Nonsense. Since when does a barbed wire fence stop the wind fields in meteorology? So, and here's a MODIS scene showing 4 fires one day. The smoke's going up toward the desert and then dissipating. It's usually convected high, doesn't get into people's lungs on the ground, and so on. So if that's, if Santa Ana's were normal, it should be transcend through time. So now look at the dates in the upper right. In the last 20 years, in the San Jacinto Mountains, San Bernardino Mountains, San Gabriel Mountains, most of it's in red, the Santa Ana winds. Now we're going to go back through time into the pre-suppression era. So, the previous 20 years, the same thing. A lot of Santa Ana winds, especially in the San Bernardino Mountains. 50 to 69, wow, suddenly it's a mix. Heat waves, marine air, less Santa Ana. 20 to 49, note the green now, it's increasing. This is before suppression was very sophisticated. And in the 19th century, it was nearly all of it going in ordinary weather. Suppression has pushed the fire season from summer to fall, from slow burning in ordinary weather to fast burning in extreme fire weather. And it all goes back to initial attack. It all goes back to that. So, what percent of the landscape is burning Santa Ana winds, showing differently? It ranges from less than 10% before 1930, and it's been more than 50% since 1970. There's no evidence that Santa Ana wind frequency has changed. None at all in the meteorological literature. We are pushing the fires into that condition because it's easy to put fires out in nice weather. It's fire selection. And it's another way of showing the total acreage or the percent acreage going from 1880s to the present. You can see where the green has shrunk down and the reds have increased through time. This is a management impact. Okay, fire durations, flaming days. We don't have enough time for that. I'm going to point out that mainly the durations are very short and sweet in California, and the fires go for long durations. In Mexico, to this day, they still have fires going 2 and 3 months on the Baja California side of the border. So they have these are fires that are going to sample climatology because they're spreading over 80, 90, 50 days, not just 2 or 3 days. And the longer the time span and the duration of fires, and this is a real law in meteorology, but the greater the time span you work with, the more it's going to resemble climate, the actual normal condition. It's only, we're pushing them into those really extreme events. Another one, crude burn rates per day. We seldom measure fire spread rates, and we still don't do it very well. It's hard to do when you've got smoke in the way. How can you measure how it's going to change? But one way you can do it is just you take the acreage per day, or the total acreage of a fire, and divide it by the number of flaming days. It's crude, but it's the best I can do. And what it shows is that the burn rate in hectares, sorry, increases through time. Increases through time. It used to be hundreds of hectares per day. A hectare times 2.5 is an acre. Okay? And now it's thousands of hectares per day. In which situation can you protect society? A fire that's goofing off in the canyons, or one that's raging in the St. Anna land?
Has the Santa Ana increased in velocity and speed and everything?
Not at all. We are pushing by suppressing fires, we're selecting for fires that get large to occur in more extreme weather than by chance. The Santa Ana being the epitome of it. It's the worst possible weather conditions. So this is the Cedar fire going through Scripps Ranch. And nothing to do with something like that. The winds were running 50, 60 miles an hour. No humidity, effectively zero. And this is Cuyamaca State Park, when it used to have a forest. And now it's gone because of this day in extreme Santa Anas. And here's a couple of fires in Baja. I just shoot it out the windows. And they're creeping. They don't spread fast, and they're in ordinary weather. I call it slow burning. And we need a lot more slow burning if we're going to manage fire here. We can't just say we're going to put out every fire ASAP, because that management will kill us in the long run. Burning correlates with drought. Well, here's a running, moving average from 1880 to the present, and it shows our hot, wet periods and dry periods through time. And here is the amount of burning per time, increasing through time. But it doesn't really correlate one against the other. I'm going to look at it differently, because we always hear in the newspapers that when we have drought, there's more burning. And the answer to that question on an annual basis, it's random. You can have a lot of burning on wet years and dry years, or you can do running averages. 5-year running average, just noise. 10-year running average, it's noise. There is no relationship in the amount of burn area and how dry it is. Why is it noise? Because it's the patch structure that dictates the burning, not the weather. The only correlation that was decent showed up in 1890 through 1909. That's not bad in R squared. And in that period when there was no interference, we had more burning in a drought in the late 1800s and less burning in the other years. But with suppression, it gets even more random when you restrict fires to specific conditions that take off on you, that represent the extremes of the climate. Burning is more extensive in global warming. Well, here's the profile of temperature since 1950, but lots of the curves you see in the literature go back to 1880. And the global temperature has gone up to 0.8 degrees C, which is about 2 Fahrenheit. And is there real evidence that our burning is due to that? First of all, I'm going to dismiss the Santa Ana part, because we already show that it's increasing drastically. And so we're pushing our fires into a different condition than what nature did for us in the past. But let's go to the temperatures, the maximum temperature that LA, Riverside, and Needles, EED, during periods of onshore flow. I'm sorry, I'm going to have to do it this way. And the temperature, the maximum temperatures of Riverside and Needles were much cooler in the pre-burning era compared to present. Examples from Riverside went from 86 to 96. If you look at all 3 records that are continuous through time, the maximum temperatures have increased 3 to 4 times faster than global warming. I'm able to distinguish global warming from the effects of management. You have to appreciate that. So I'm saying that fire selection is kind of pushing us in the direction of global warming, whatever it may take us by 2050 or 2100. But in fact, the extreme fires are taking place in weather conditions made more extreme through the management practices of initial attack. 3 to 4 times faster. So, and then other evidence is against the global warming hypothesis. The increase in fire size in Baja California and Southern California are not synchronous. It should be synchronous if it's global warming. It's not. It started in 1900, Southern California, and in the 1980s, really, in Baja California. And those are related to the onset times of suppression. So, this is what I call fire selection. Non-random fire occurrence in extreme weather states compared to chance. We now have fires in extreme weather, anomalously old fuel age, although not that much in Chaparral. Homogenization of patch structures, that means the patches are getting bigger and allowing fires to get larger. And large fires are also getting increasingly synchronized in space and time. Have you noticed we've had fire sieges, 5, 6 other 7 major fires at once, 2003, 2007, 1970. It used to be willy-nilly, fires here, then by chance over time. Now they're getting synchronized to the extreme weather states. And that makes it a lot harder to try to fight fires when you've got 5 monster fires going on at once. Can't do much. And then the people who are pushing the global warming hypothesis is this silver bullet called 1985. Suddenly the fires are much bigger. And the problem with that whole thing is they're not accounting for the effects of suppression across the western United States over the last 100 years. There's been tremendous increase in biomass all over the region. It's totally anomalous. If you're going to account for global warming, you've got to account for the effects of management. So, you know, I hate to be in a negative mode here at the end, but there's a marriage between government and science tends to corrupt the science. It's not just this. It happened during the Dust Bowl period. There's a lot of Dust Bowl politics in manufacturing, for example. And so, you know, Orwellian, I just went to Wiki to see what it meant exactly. The societal condition that's destructive to the welfare of a free and open society. It denotes an attitude and a brutal policy of draconian control by propaganda, misinformation, denial of truth, and manipulation of the past. And believe me, that has all been going on for the last 100 years. So the question you need to ask is fire science an Orwellian nightmare under global warming? It's a difficult process to try to connect global warming to lots of issues. Unfortunately, in the political world, a new hypothesis, in this case, global warming, tends to go into, it gets immediately transmitted all over the world in different dimensions, different scales, and there's been really classic overreach. In some cases, when it comes to meteorology, and I must tell you, that's one of my disciplines. I'm a meteorologist as well, and atmospheric science. There's definitely good research going on that's testing that hypothesis. But what happens when you get into the very complex world of biology? It's not easy. Meteorology is supported by physical laws that you can work with. All we have in biology and biology and ecology is Darwin. And Darwin's a powerful idea, okay? Natural selection and evolution. But it's a grand theory, but it also says that every species has its own history of natural selection and evolution. In other words, grand theory can't transcend. You've got to look at each species one at a time and try to make sense out of it. And likewise, here you're just looking at species growing in consort and burning, chaparral, for example. It's not easy to try to connect global warming theory to complex systems. Very difficult. You got to be patient with it. There may be something ongoing, but there's no silver bullet out there. Thank you.
What do you mean by your last sentence, there's no silver bullet out there?
Say again?
What do you mean by your last sentence, that there's no silver bullet?
There is no strict evidence that says that global warming is affecting the fire regime. I don't see anything going on. As long as I see this magic boundary between Mexico and the United States and the difference in fire regime on both sides of it, in both countries, it's hard to explain how global warming is going to have an effect when you've got such differences going along the political boundary. In the back.
How would you explain, in the 70s, if we understood suppression was, we need to tear the understory, we understood the science, and yet it didn't take applied action adequately in the last 40, 50 years?
That's a great question, and I call it the death spiral between three sectors of society: the media, the public, and the managers. And they all feed on each other downhill. The media makes money selling newspapers, or in the old days, and many other media now, by saying there's a big fire, so people spend more money on that. The Forest Service is largely budgeted through firefighting. And then the public demands certainty, when in fact they don't appreciate that certainty is not possible when you're dealing with nature much more powerful than man. They feed on each other.
There was a concurrent, common, I guess, occurrence of anti-intellectualism in our nation, and that is in politics and in media. Do you think that played into it? Rebellion, I'd say, I don't know. Or was it just, I don't want to say the Reagan era on, but it kind of seems that way to me. We had not pretty awful, I won't qualify it, an awful EPA manager for Reagan, and that just kind of continued, that the staff and everything.
I really think it comes down to the fact that, and this is really critical, is that the promise of fire protection, which goes right back to 1900 roughly, has given people license to put houses in places where they don't belong.
That's what I was going to ask about, whether there have been any studies since the variable of population growth in the region over the last 100 years, and whether there's any correlation.
Yeah, well, there's certainly population growth. Southern California is kind of unique in the United States because we had the forest reserves and then the national forests come into creation, and these federal lands were never committed to urbanization. Those areas which are urbanized, like Idlewild or Lake Arrowhead and Big Bear, were already in private hands. So, and they could not buy those lands out. So, Lake Arrowhead is going to have its day in court of nature not long from now, because the last fire in Arrowhead is in 1879, and they're going to get ripped to pieces. Okay, as a result, we have discrete boundaries between wild and urban. This is the most, I lived a year in Wisconsin and hated it, okay? You leave the city, and the city gradually thins out, and then you got a bunch of scattered houses, and then you got a bunch of farms, and then if you're lucky, you'll see a plot of trees somewhere. But in LA, you just go from concrete to nature, side by side. It's really remarkable. I don't think there's any place in the United States quite like it. But we still have them side by side. And the watershed idea is legitimate in the sense that, yes, we get more runoff off the mountains, especially the San Gabriel range, after fires. and people want to be protected. I'm not sure if I'm, as fires get more severe, we're not protecting houses. We really aren't, okay? And we make them with wood frame. And my wife's from Greece, and I go to Greece every year, and to Athens. And there are fires around that city all the time, and they never lose a structure. It's reinforced concrete, and no wood on the exterior. Okay? And that's true of most of the Mediterranean cities. Okay, but here we build structures that burn down.
What do you think the effects of the European non-native grasses are?
Oh, great, yeah.
Equation?
Well, I showed the maps, and I could go back to them, but the main effect is in certain areas of low elevation where the grasses have invaded. They're winter grasses, mostly living below 3,000 feet. And so those mountains that are under those criteria have been had coastal sage scrub mostly replaced by grass. And the fires have increased, especially in wind-prone areas such as San Gorgonio Pass. Some places like the south face of the San Bernardino Mountains, that's going on, and there's also some interface areas in San Diego that are having more frequent fire.
But do you think that that explains some of your,
No, only in the low elevations. Only in the low elevations. Because the chaparral and the mixed conifer forest, the grass invasions aren't really happening, partly because chaparral's impenetrable and thick, and these grasses can't really invade it well. And in the conifer forest zone, it's too cold up there for these grasses, these same species. I've seen these grasses in Europe, and it's weird, but they're not nearly as abundant as they are here.
but what about like type conversion, converting from chaparral?
I've seen it locally. The Box Springs Mountains right behind UCR have gone from sage scrub to grass in the last 40 years. There are a few other areas, but it's happening in sage scrub more than chaparral. And I've never seen a type conversion related to grass and forest. It's not happening. It's mainly the low elevations where these grasses are most happiest, bromes and oaks, things like that.
You showed the earlier slide where I had the ash fires, which created holes in the chaparral. Could you recreate that? How big is a necessary patch?
Yeah, what, I'll just buy into nature here. Baja California, the modal fire size is 1,000 hectares. It's 2,500 acres. And it can be bigger, up to maybe 10,000, and then there are lots of them that are smaller than that. But that was that's about the size frequency distribution there in Baja California as well as in Southern California before 1909. And then it enlarged after that. So the goal would be somehow to get back to, now one way to do it, and they're doing more and more of this in areas that are more remote in California, such as this national parks, and also in the Kern County Plateau area, for example, Southern Sierras. They're now just saying, fire started, it's a good place, there's no land use, we're going to let it roll. And you not only get patchiness with more fires, but you get patchiness from low-intensity fires that are reticulating. They weave through the landscape and make patches on their own, many of them. And so you get, like those two pictures I showed you, what a Mexican fire looks like. They're not threatening. By the way, they don't lose houses down there either. They use cinder block in most construction down there. Yes?
In the Kern County Sequoia areas, I'm curious about the effect of soot and oak death. And it seems that fire going through that kind of landscape would just be devastating.
You're worried about ceanothus?
Sudden oak death.
Oh, sudden oak death.
Yeah.
Okay, sudden oak death, I actually know something about that too. First of all, it's a misnomer. It's really sudden lithocarpus death. And it's really hitting tan bark oak. much more severely than all other species. And secondly, the sudden oak death is mainly along the coastal strip. I've mapped the entire destruction of lithocarpus in the San Lucia Mountains from Monterey down to Cambria. And what's interesting is that the mortality is right on the slopes that are facing the ocean, and as soon as you're over the ridge on the other side, there's none. The reason is the Phytophthora, which is the pathogen that kills the trees, require a long time of continuous wetting of leaves before the infection will take. And it was thought by the people in Berkeley and Davis that it was due to continuous rains to initiate. It's not, it's fog. And the fog is largely restricted to the coastal strip. So there's a lot of area, it's really not impacting the Sierras, and it's not impacting the leeward slopes of the coast ranges either. And so far, it's not been detected in Southern California. Yes?
This thing of allowing the fires to continue in the national park, is that a reversal of the theory of suppression? Are they aware of it?
Oh, they're aware of it, but they're, I don't know, there's so much politics behind it. And then down here in Southern California, the public wants certainty. You know, and they're getting it. We just have less days with fires, but we're going to have more days where we're going to have thousands of homes burned down, like in 2003. You got to take this in long-term consequences, and unfortunately, people are not looking at it in terms of long-term unintended consequences. I think that the more the Forest Service does, they do have that choice, by the way, if there's a fire in this appropriate situations of land use and weather, and they do have the option of watching it. It's a lot more common in the Great Basin states than it is in the Pacific Coast states. Maybe the word gets passed around from foresters in the interior to the coast. Yes.
When you say watching, you mean let it burn?
Yep.
The fire several years ago in Yellowstone, they had that same condition. It was lightning strikes that started that, and they thought, we'll just let it burn itself off. It didn't.
Well, it went a whole summer, and it was an extraordinary drought. That usually doesn't happen in the summer in Yellowstone. And it's lodgepole pine, and I don't like comparing lodgepole pine to chaparral. We do have lodgepole pine on our peaks, and in San Gorgonio, we just took out about 3,000 acres of it in 2015. Yeah.
Again,
But lodgepole normally is crowned out, or killed at the surface because the bark is thin.
but the idea, I would think, would be the same if they're just going to let it burn itself up, no matter where that fire might be.
If you have a really good fine-grained patch mosaic, it's not going to go explode into a large fire. Mexico proves that. But you got to get that mosaic back. Yeah, I wish, and it should be only restricted. I'll tell you, it should be restricted to land use interfaces with the wildlands, first of all, and secondly, it's not cost effective. It's prohibitively expensive. Cost per acre, you got to ask that question. And if you allow one to move, they had one in, like I said, in the Kern Plateau area. They went 2 or 3 months last summer. That cost per acre is really small compared to a controlled burn. Controlled burn, you'll never keep up with the growth of the vegetation with that management scheme. It's a nice idea, but and it can be really good if you're looking at the interface of individual towns and like the margins of Arrowhead or something, or Mariposa, and there they had sheep and cows helping out, okay? But it's prohibitively expensive. It won't happen.
The current fire right now by the 91 freeway in Anaheim Hills?
Yep.
In the Chino Hill State Park?
I don't know if it's in the Chino Hills. I think it's on the south side of the 91 in Gopher Canyon and Coal Canyon in there. but I'm not aware of it I was listening to news on the way down, whether it's going into the grassy hills, and they weren't talking about it there. I think it's on the south side of the 91, unless you know.
It's a different location. They'll have repeated fires on the north side, like over the years.
Yeah, because it's grass. That's key. Grass will burn every year. And the amount, and a lot of the burning in LA this year, and I predicted this in the newspapers, is going to be a grass fire year because it rained so much last winter. And because of the high rainfall, it's postponed the fire season in Chaparral till later than normal. Compared to the drought we're having fires breaking out in May and June, and then this year really we've had no major fires in Chaparral until perhaps today. The fuel moisture was really high in Chaparral this summer. Yes.
Now, I understand that there's a probable correlation between more frequent and longer droughts and global warming. What was it, 3 or 4 years ago, I lived through the rough fire in Kings Canyon, Sequoia. Started at high elevation, and the plan was to let it go. But it encountered, because of the prolonged drought there, this nexus of tree death caused by bark beetles.
The ponderosa pine. Ponderosa pine.
Yeah, and
Mostly
so
that.
it got much larger than they intended. They ended up having to control it when it got out of.
Well, that may be true, but you got to account for the fact, 2 things. One, there's been suppression on that land for 100 years, and secondly, most of that area was cut over during the gold rush, and the forest was made younger and thicker as a result of that.
That's true.
So,
That's true. But there was also a lot of dead trees.
Yeah, but you know what? A dead tree, if it's full of foliage, is explosive. I have no trouble with that. But that dead tree loses all its needles after about 3 or 4 years. And guess what? Now it's a big fat ball and it's not flammable. So it's not really okay. So just because it's dead doesn't mean it's more flammable, unless it's freshly dead.
They were freshly dead because of the bark beetle. and
Sure.
the ground.
But the reason the forest was thick is because there are too many trees due to suppression. So we got to go. So I did a study, and it's out, that compared the tree death in 2002, which was a real huge drought here in Southern California. Lake Arrowhead lost, millions of trees, for example, at once. And on the Southern California side with the Mexican side, where it's got free burning and nice open park-like forests. And guess what? Mortality on our side of the border was 6 times that than the other side, because there were less trees to die and there was less competition for water. Yes?
So what's the solution from your research?
What, say again?
What's the solution from your research? And I'm hearing suppression has created a new problem. It's changed everything.
Yep.
Maybe we should build houses out of concrete like they do in Greece.
I'm not against wood frame housing in an earthquake, and I'm not against housing that is consolidated development, that has lawns, it's concrete, okay?
So that helps suppress.
Yeah, because lawns, concrete, and asphalt are non-flammable.
Then you're really asking.
Idlewild, you're asking for it. There are parts of Fallbrook that are pretty messy, especially toward the freeway. You got an interface here, it's not clean.
So how does this idea of Forest Service rethinking this idea of suppression, is it your kind of research that's going to create that, hopefully spark that?
I wish.
Yes.
If anything, when I'm done, and I'm gonna, 6 feet under and whatever, in the long run, I know I'm gonna haunt them.
I came in 5 minutes late and I'm haunted by it, and I heard on the news that 9 out of 10 fires are man-made. And I came in and of course I'm totally impressed with the body of your knowledge and your theory, and it's a question, but is that a true fact? And how do I take that home? What do I do with that?
Again, you're mixing up scales.
Okay.
Ignitions are instantaneous, the vegetation gets flammable over decades. It's unfair to make that association whatsoever. It's Orwellian nonsense.
It's a go-on, okay.
Well, but the coastal plain is not a lightning prone area, so if you took away urbanization as an ignition source, what's the natural source of the fire here? And what would be the frequency?
First of all, I'll challenge that comment because I've looked at lightning detection network data along the coast, and it's not free of lightning. And it's more than you think, but you have to look at the data over decades of time scale. You have a rate of about 0.5 ignitions per square kilometer per year. Riverside is about 1 strike per square kilometer per year. And the mountains run 2 to 3. Okay? The ignitions go right to the damn islands, actually. The fires out there in San Clemente. Guadalupe Island, not Guadalupe. Yeah, it was Guadalupe. Now they got rid of the goats. And the first thing that happened, they had a major grass fire go all across it within 2 or 3 years. Now, there's lightning out there, and as long as you've got any kind of potential for ignition, lightning ignitions and atmospheric instability, it's not dependent on the mountains. It can be any kind of circulation system that runs through here. So lightning can happen. Now, the answer to the question, though, and I know something about this because I wrote a book on California's fading wildflowers, and that's the title, that the Orange County plains and the plains of LA and San Diego were covered with flower fields. The Native Americans burned it because they got something out of the resource, food. They burned and then harvested the seed plants that were useful, such as chia. And they actually made little haystacks of them all over the place when they harvested. And and one day this is when the Spanish were going through there, Crespi recorded this, but the Indians were pissed off because the horses were eating their little haystacks. Says, could you please move on and stay away from our food? We're harvesting for the summer. But they did this, and there were burns recorded by Crespi from northern San Diego County all the way to San Francisco that year. Major ones. They were complaining that there wasn't enough feed for their horses when they were moving up the coast. So the flower fields in the coastal part of California actually had enough biomass to carry fires. That's what it tells me. Now, the Native Americans accelerated the process because it was flowers and annuals, which you can burn annually. You can't do that to chaparral. But at the same time, in the interior valleys and in the Central Valley, fires are not recorded. There were flower fields there, but there wasn't enough biomass to carry a fire, and a lot of the species, such as the California poppy, would, after drying out, would disarticulate and just crumble to the ground and with a little heap, and there was nothing left. And so the interior areas and our deserts really didn't burn under the flowers. But some of the species really cured well. I'm thinking of Encinkia, Phacelia, and Chia. And there's one other genus I can't think of. It probably carpeted the coastal plains where it was cooler summers and they had much more productive annual wildflower fields. There was not bunchgrass. That's totally erroneous. It was a story made up by Frederick Clements. There was never even looked at the history of it. So desert flowers can carry fires. When in 2005 was the wettest year in the Mojave Desert we know of in instrumental records. And there was 100,000 acres of Mojave Desert burned off the next 2 years. What? From fiddleneck and Encinkia, a wildflower species, carrying a fire. So the claim that exotic grasses are causing more burning, that's not really true. Because we know that these areas, even the deserts, burn once in a while.
I may be wrong, but over the last
5 to 15 years, in the fire service, they used to do prescribed burns to burn off some different areas and patches and some of the valleys where the dead brush would build up. And over the last 5 years, those kind of burns that were done by the fire service, whether it was federal, state, or local, in certain areas where there was excessive buildup of dead material, sometimes 8 or 10 feet deep in these canyons and stuff, they would go in and burn it out, and it would be controlled. They had a couple times where they lost control and they burned up a few houses, but it seemed to me that because of liability and some other reasons over the years, because that was the kind of work I was in, they stopped doing them. And whether that was a beneficial thing or it turned out to be not beneficial. Okay, I'll go say two things about that. First of all, yes, I'm glad they do these things, but the scale is inappropriate. They can't keep up with the growth of the vegetation. And secondly, one outcome, ignition causes fire. And Earth surface process became criminalized.
Yeah. Say again?
Earth surface process became criminalized. And the legal system should have nothing to do with it.